Welcome to Study Loop.
Physics, Chapter 9, Problem number 104. In this question, it asks us to discuss why there are tidal effects in both Earth's crust as well as Earth's atmosphere. So we know what we know of tides are what we consider tides in Earth's crust, right? The oceans that lie on Earth and the tides that have we experience in the ocean is a combination of the Earth spinning. Where the reason that we get these high tides is a combination of Earth spinning and the sun and the moon's gravity. More specifically, the moon, just because it's much closer than the sun. But this combination of gravitational forces from the moon and the sun, as well as Earth's rotation, create a sort of imbalance of one very high side and one's very low comparatively, uh, based on where the moon is and where how our Earth is spinning. One side is going to be one side of the water level is going to be higher. Like for example, if the moon was here, I'd say generally it would be higher tide on this side of the globe, and vice versa. And the same thing for the opposite side. We have lower tides on the other side. Um, and that's generally how we discuss, how we know about tides in regards to Earth's crust and Earth's oceans. But sometimes what this question brings up is that there are also tides in Earth's atmosphere. Now, here's a kind of just layering of Earth's atmospheres from the very thin part here with the blue, from the blue line to the black line here is the maybe the gas of our atmosphere, and then we have the crust from the black line to the red line, and then more of the inner core here, further on the mantle and all that other stuff. But so there are actual tidal forces on the atmosphere itself, and this is due to Earth's magnetic field. We have, as we all know, that mantle is made up of magnetic material, iron, copper, and these they're like in a sort of soup. They're a very melted consistency, and they're constantly flowing. They're constantly moving with convection currents, and this moving of these magnetic materials is what gives Earth its magnetic field. And this magnetic field also is one-sided of the other. North, we have poles, and it's different where the poles. It's not as strong where the poles, come to meet and all that. And so this also imbalance in Earth's magnetic. It's not a uniform magnetic field. This imbalance is what also causes tidal forces to occur in the particles in the charged particles in Earth's atmosphere.